Dr. Liam Brittle. I'm the application manager for the Graphene Engineering Innovation Centre's printed laboratory. So we're here doing some screen printing this morning. We've got one of our standard frames, which I'm just adjusting into the jig now, which enable us to hold smaller prints. So these might be really small on a sort of wafer scale or up to sort of meter by meter scale prints, depending on the requirements for the application. And we will be doing regular screen printing, and we can get resolution down to around 100 microns line tracks. I'm just getting the frame in the correct position. We don't need to get it absolutely perfect because we have alignment cameras on the machine. I finished with that now, so I'm just going to double check that it's not going to shift. The screen doesn't go under a lot of strain, but it can pull out during the printing process. So, and the print head's already in the up position, so don't need to worry about that. So I'm just going to clamp the screen in place. Now it's going to ask me, so I need to tell it which size jig we have in. So we need to do some alignment of the squeegee and the flood blade. So I'll fetch those now. So we've got two tools which we're going to put into the print head now. So we've got the flood blade and we've got the squeegee. So the job of the flood blade is to evenly distribute the ink over the surface of the screen and fill the mesh which is going to hold the pattern. And then we're going to use the squeegee to push the ink through the screen and in the pattern which is already on the screen and produce the pattern on the printed part. The squeegees have different shapes, different sizes. Obviously, you can choose the width depending on the length or the width of your pattern you want to print. And the angle of this beveled edge is going to work with the ink to force it through the screen. You can have different hardnesses, different angles, which are all going to affect the print property. So we'll put them in the screen now, in the print head, sorry. For the squeegee, we're going to use the pneumatics. To do that, for the flood blade, we'll use what's called the hard stop. The squeegee's already been aligned, so I'll just bring it down so that we can check the height of the flood blade. So the way this machine works is it's got a table. We'll put our paper or whatever material we want to print to onto the left-hand side over here. When it comes to printing, the table will move into the correct position. We'll raise in contact with the screen. We'll have already covered the screen with ink, and then the squeegee will move down, contact the screen, and pull the ink across the screen and through the pattern. So I'm just going to move the print head further to the back so we can check the height. Right position. We want it sitting just off the screen so that when it pulls the ink across, it just leaves a thin trace on the surface. So push this down. So normally before printing, we want to do a quick mix, check that nothing's settled. Carbon inks or graphene inks are often thixotropic, which means that they will shear thin. So the faster we move them, the less viscous they will become. So after you work it for a short bit of time, they will become slightly thinner, otherwise they're quite thick. All I'm doing here is just checking when the flood blade's not in the down position that it's going to collide with the frame. So we're going to quite liberally apply ink to the screen. Usually the wastage in this process is less than about 5%, but we can recover all of the unused ink or most of the unused ink at the end. But we need to make sure that there's plenty enough in order to coat the screen. Yeah, the last thing I'm going to do before we print is just to put a little bit of the ink on the blade of the squeegee, so that it doesn't create friction with the screen. Okay, so I'm going to put the print head into the printing position now, and then with these two bolts we'll secure it. Secure it so that it doesn't move during the printing. So we have ink on the screen, we've got the screen positioned correctly, we've got the squeegee and the flood blade in the correct positions, we've checked the front and back position. So now we can go to print. So we're going to put the paper which we're going to use for printing today onto the vacuum table. So we taped off the unused vacuum holes in order to let the vacuum hold the paper securely. We're just going to test that by turning the substrate vacuum on. And you can hear the blower wind up there. Okay, so now we've got the ink on the screen, we've got the paper in place. The first thing we're going to do is move the paper into the printing position. So we need to move the table to the right. And now the table is in the place where we need to print. But now we need to coat the screen with ink. So we'll move the flood blade to the back. We will drop the flood blade into the position that we set before. And then we will coat the screen with ink. We'll now bring the flood blade up. We'll bring the table up so that it's touching the bottom of the screen. We will bring the squeegee down, and then we will bring the squeegee away from the screen, bring the table back down, and bring our print across to the... So after we finish printing, we're going to need to cure or dry the inks in an oven, usually at around 100 degrees, perhaps for up to 20 minutes, but some inks dry much more quickly than that. And then we can start doing some basic testing using a voltmeter. And we'll just simply check two-point resistance at various points on the sample and compare them place to place. So this is a standard test pattern that we had produced for comparing different inks. And we've got some standard designs on here. So we've got these cloverleaf shapes, which are usually used for measuring the sheet resistance accurately. We've got a couple of antenna designs. So this would be a kind of RFID type antenna. This is a simple dipole antenna. And then we have other structures. Often this serpentine shape might be used for heaters and also be used as strain gauges. And then on this side, we have various patterns which are just used to check for print fidelity. So these crisscross patterns, we can check for bleeding at the corners, the definition of these lines, and can look for breakages on the thinnest lines. So if we're looking at a conductive ink, that's going to be important to ensure that we get continuity in the circuit. And then these other simple designs are used for things like thermocouple, printed thermocouples.